Everyone, today we're going to learn about another type of reaction that can take place in an aqueous solution. In the last section, we learned about precipitation reactions in which you need a solid as your product in order for it to occur. In this section, we're going to learn about acids and bases reacting together in a reaction called neutralization. So since this is an acid-base reaction, let's kind of go through what an acid is again versus a base. So acids are substances that ionize in an aqueous solution to form hydrogen ions. In other words, they make the hydrogen ions to be able to give away. So a hydrogen atom consists of a proton and electron. So if you just have an H plus and you have gotten rid of your electron, that means you're just simply a proton. Thus, acids are often called proton donors because they create them to give them away. Depending on what type of acid you have, they're going to create a different number of proton ions or hydrogen ions. If you are monoprotic, mono meaning one, you're going to tend to form one hydrogen ion. A good example of this is hydrochloric acid. We have our H+, we have one of them, and then we have chloride, -1, so you only have one hydrogen. Diprotic means two, and this is going to yield 2H+. A good example of this is sulfuric acid, H2SO4. If you split this apart, that 2 does not belong there, so it comes out front. So I have 2 hydrogen ions and then 1 sulfate ion. Bases, on the other hand, accept or take in that hydrogen ion that acids give off, and they produce something called hydroxide or an OH -1 ion. This is very characteristic of bases and help you identify them. Some common ones are going to be things like sodium hydroxide, potassium hydroxide, and calcium hydroxide are very common. However, there are some compounds that do not have OH as part of their equation, but they can still be considered bases. The one I had you guys write down is ammonia. This is an NH3 ion. This is a very common base. In fact, it's a weak base, so it's a weak electrolyte. Please note that the reason ammonia is a base is because it still accepts the hydrogen ion that acids give off, and when they do this, they're able to form hydroxide ions. So as a general rule, let's go back over our strong versus weak acids. Remember, we learned about electrolytes and if they're a strong versus weak electrolyte. If they're a strong electrolyte, these are going to be things like strong acids and strong bases, which is why we listed the 7 strong acids below. If they're weak electrolytes, they're going to be weak acids or weak bases, and they will not be found on this little table that was given to you in class. So let's go over, now that we've talked about acids and bases, well, what is a neutralization reaction? All it is when an acid and a base that are solutions are mixed together. What happens is they create two products. The first product they always create is water, which will be written as H2O in liquid form. The salt is also another product, and it is defined as any ionic compound whose cation, which is that positive charge, comes from the base, and the anion, your negative charge, comes from your acid. These are a special type of double replacement reactions, so we will find the products the same way that we found products for our precipitation reactions. So I also note that we're going to be doing ionic and net ionic equations for acid-base reactions as well. So let's go over the general rules that we need to remember. Remember, only water-soluble, which means they have an AQ after them, strong electrolytes can actually dissociate into the ionic equation. Weak electrolytes, such as weak acids and bases, do not form ions. Also remember, solids, liquids, and gases do not form ions either, and we don't split those apart for the ionic equation. Lastly, that solubility table is going to be your best friend. Make sure you're always consulting that and looking at that to see if something is soluble or not. I just want to bring this picture up, and we're going to see this happen. Whenever a strong acid reacts with a strong base, the net ionic equation is always going to be the same, which is A hydrogen plus hydroxide yields water. So if you ever see strong acid, strong base, this is automatically going to be the equation. We're going to see that in one of the examples we have coming up. So here again, I brought our strong acids and bases up again because we're going to refer to it when we use this equation. So I want to write the molecular, ionic, and net ionic equations when these two react with one another. So let's write our base equation. We have hydrochloric acid. It doesn't tell me what it is, so I'm just going to leave a little blank for it. Magnesium hydroxide. This also does not tell me if it's aqueous or not, so I'm going to leave a little blank for it. And this is automatically going to yield water, which again is a liquid, and then some kind of salt that we're going to have to find out. So just like your other ones, we split apart our ions. And you always split apart both of them regardless if they're aqueous or not right now in order to find your product. So I'm going ahead and doing that right now. Notice my H and my OH makes my water, and here my Mg and my Cl are going to make one of my products. So I'm going to cross my charges, Mg, Cl2. From there, this is going to take place because I have an acid and a base. So this reaction is going to occur regardless. And what I need to do is to figure out, well, are they going to be aqueous or a solid? So let's go refer to my solubility table. We're going to look at chlorine first, and we're going to see if hydrogen and magnesium are an exception. Here I found my chlorine. Neither hydrogen nor magnesium is an exception, so both of them are going to stay AQ, which is soluble. The other one we're going to consult is OH and see if magnesium is an exception. So here down below is my OH. Magnesium is not an exception, so this one is actually going to be a solid. From here, we can go ahead and we can balance this equation. So I know that this equation is going to balance out as 2, 1, 2, 1. We can go ahead and write our ionic equation. Remember, ionic, you only split strong aqueous solutions, so things that are strong electrolytes in an aqueous solution. Here, this is an aqueous solution, and so we just have to see, is this a strong acid? If we consult our table, hydrochloric acid is a strong acid, so we can go ahead and split these apart. So here we have an H plus ion and a Cl negative ion. Remember, this coefficient in front gets distributed to both, so we have 2 hydrogen, 2 chloride. Over here, this is what's going to stump a lot of people. This is a solid, so you cannot touch it. You drop it as is. Over here, this is a liquid, so you cannot touch it. You drop it as is. So you still keep that 2 there. And then the last one, this is aqueous. We know that this is a strong electrolyte because magnesium is a metal. So we can go ahead and split this one, Mg. And then we have a Cl negative. Please note that 2 does not normally belong there, so we got to bring it out front here, 2 chloride. Once you get that, you can go ahead and write your net equation. You do this again by canceling the same on both sides, so these 2 cancel, and that leaves me with 2 hydrogen ions, my solid magnesium hydroxide, my water, and my magnesium ion, because it's different. If you have any questions, make sure you stop this video and then make sure you email me or come up and ask me. Here is another practice one. Here, I'm giving you this practice one, which is a strong acid and a strong base to show you that you get the same reaction as the one I showed you earlier in the lesson. So let's go ahead and write the molecular equation. H2SO4. It didn't tell me what it was. NaOH did not tell me what this one was. This is always going to yield water and a salt. So let's figure out what my salt's going to be. First, again, remember you always split it into the ions to find the product if you're still having trouble visualizing that and doing that in your head. So here, what's left is my Na and my SO2 4. So I go ahead and split my charges. So I get an Na2 SO4. And I don't know what that is. From there, you can go and see if it's going to be aqueous or not. So we need to check my SO4s and see if hydrogen and sodium are. So SO4, hydrogen and sodium are not part of mine, so they're going to stay AQ. Let's check our OH. Here's my OH. Na is an exception because Na is an alkali metal, so that actually brings it up to be AQ. From there, make sure you don't forget to balance because that's what most people often forget. So I need a 2 Na here and then a 2 here in order to balance. From there, you can go ahead and do your ionic. Remember, aqueous solutions that are strong electrolytes. So here and here, let's see if this is a strong acid and a strong base. Note here, here's my strong acid. Here's my strong base. So both of these are going to split into its ions. So let's go ahead and do that now. We got a H plus ion. That 2 does not belong, so it comes out front. And we have an SO4 2 negative ion. This is going to split as well because we just checked that's a strong base. The 2 goes to both of them, so 2 Na plus ion plus 2 hydroxide ions. Remember, water never splits because it's a liquid, so we drop it as is. And then this one will split because it is aqueous, and here we have a metal. So we can go ahead and split this as to 2 Na. Notice that 2 doesn't belong there, so we threw it out front. Plus SO4 2 negative. Okay. From here, we can cancel what is the same on both sides. So sulfate is the same on both sides, and sodium is the same on both sides. When you rewrite this, you get 2 hydrogen plus 2 hydroxide yields 2 water. Please note that my 2 and 2 can be reduced. So you get H plus OH yields water. That's the same thing we saw up here. If we have a strong acid and a strong base, these two are going to yield water. And the last one is the one that's going to be a little bit different because I'm going to kind of tell you what they're going to form. Also, we're going to be working with a weak acid and see what happens when we have one of those. So here it says aqueous phosphorus acid. So we know that this is H3PO3 and it's an aqueous. Reacts with potassium hydroxide and it says it's aqueous as well. So we can just put AQ after it. It produces water. Remember, my water is always going to be liquid. And then it says potassium phosphite. So it says K3PO3. Oh, that's a weird 3. And this says this one's aqueous as well. So that's awesome because it told us a lot of what we needed to know. Here we can just skip to the part where we balance then. So here I have 3 potassium. I need 3 potassium here. When I look over here, 1 phosphite, 1 phosphite. I have 2 hydrogen. But this one, I have 6 hydrogen. So I need to put a 3 out here to give me 6. And then let's count my oxygen. So here I have 3 oxygen plus 3, that's 6 oxygen. 3 and 3, I'm balanced. So 1, 3, 3, 1. From there, I can write my ionic. Here's where I wanted to do this example. I have an aqueous, so a lot of people will think you need to split this one apart. But notice H3PO3 is not a strong acid. So we cannot actually split that apart because it does not fall in this category. So H3PO3 does not split apart into its ions. It stays as AQ. Over here, KOH, K has a metal in it. So this is automatically going to split apart. So here we've got 3 K plus ions, plus we have 3 OH negative 1 ions. This splits into water. Water will not split because it's a liquid. So 3 H2Os plus this one, it's going to split because here it's a strong electrolyte because we have that metal. So that 3 comes out front, 3 K plus. And then over here, this gives me a PO3 negative ion. From here, you can cancel what's the same on both sides. So my K's are, and that's going to leave me the following. H3PO3, which is aqueous, plus 3OH negative 1, which are aqueous, yields 3H2O, which is a liquid, plus a PO3 negative, which is an aqueous. So notice here, if you have something that is actually a weak acid, it's going to be part of your net ionic equation. So here I have my weak acid with my OH, my water, and then my PO3 negative. So that is the end of the lesson. If you have any questions, please make sure you come up and ask or you email me. And I hope you guys have a good day.